Good day, viewers all over the world. Today we want to look at nth order linear homogeneous differential equations with constant coefficients. In our last class, we have discussed about the solution of second order linear homogeneous differential equations with constant coefficients. But in this case now, I want to do the generalization, which is nth order. Second order, n will be 2. That is, we have y prime prime. Third order, n will be 3, y prime prime prime, and so on. So the characteristics equation, that is when we want to find second order linear homogeneous differential equations, we usually convert the differential equations to characteristics or auxiliary equation. That is, we change the differential equations to an algebraic equations. So in this case now, if one is given as the general form of ordinary nth order linear homogeneous differential equations, then the characteristics equation is given as this. You know, when we have y prime prime, that will be represented by m squared. But in this case now, when we have y raised power n, it will be mn. Okay, they're followed by n minus 1. If n is equal to 2, this first one will now be m squared plus, if n is equal to 2, plus a m, then plus a naught. That's what we are going to have. Okay, and a naught is equal to 1. That's what we are going to have. So these are the coefficients j, where j is equal to 0, 1, 2, up to infinity, up to n minus 1. Then, if this is the general form of nth order differential equations, this will represent the characteristics equation, or what is called the auxiliary equation. So I want us to take two examples under this nth order linear homogeneous differential equations. So we start with the first example. Example one, where we are asked to solve y prime 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 minus 6y prime prime plus 11y prime minus 6y equal to 0. Okay, if you look at this critically, if you look at what we are given, you will understand that in this case we have the cube y all over dx cube minus 6 dy squared d square y all over dx squared plus 11 dy dx, then minus 6y equal to 0. So the characteristics equation will be, the first one will be m cube minus 6m squared plus 11m minus 6 equal to 0. So this is a polynomial equation of degree 3. Okay, polynomial equation of degree 3. So how do we solve this? Of course, we start by guessing. If we say m equal to 1, are we going to get 0? That is, if m is equal to 1 minus 6, that's minus 5. Minus 5 plus 11, that's 6. 6 minus 6, yes. If m is equal to 1, we are going to get 0. We now say that m minus 1 is a factor. M minus 1 will be a factor of this characteristics equation. M minus 1 will be a factor of that characteristics equation. So if we use m minus 1 to divide what we are given, m cubed minus 6m squared plus 11m minus 6, here will give us m squared. Then we have m cubed minus m squared. If you introduce minus, this will cancel out. Then here we have minus 7m. M minus 1 is a factor. So m minus 1 is a factor. This will be minus 5m squared plus 11m. So we introduce minus 5m here. If this multiply this, we have minus 5m squared plus 5m. If you introduce minus, this will cancel out. This will be minus. Then we have 6m minus 6. This will be plus 6. So I have 6m minus 6. If you introduce minus, it's 0. So that simply means that instead of this now, we write this as m minus 1 into bracket m squared minus 5m plus 6 equal to 0. That is what we are going to have. So then from there, from there we know that one of the factors is that m minus 1 is equal to 0, or m squared minus 5m plus 6 equal to 0. That's what we are going to get there. So that's what we are going to get there. So from there, what do? We factorize this. So m is equal to 1, or when I factorize this, I'm going to have m squared minus 3m minus 2m plus 6 equal to 0. Then I do the grouping. So I'm going to have m is equal to 1, or when I bring out what is common there, m into brackets m minus 3, then minus 2 into brackets m minus 3 equal to 0. So let's leave this and concentrate on this. I will have m minus 2, m minus 3 equals 0. It simply means that m minus 2 equals 0, or m minus 3 equals 0. M is equal to 2, or m is equal to 3. So I can now combine the 3 now. I can combine the 3. That is, I have m is equal to 1, or m is equal to 2, or m is equal to 3. That's what I have. So this will represent m1, m2, and m3. So what will now be the solution to this differential equation? So hence, we say hence, the solution is y is equal to, we can say c1 exponential x plus c2 exponential, here will be 2x plus c3 exponential 3x. That will be the solution to that differential equation. So that's how to find the solution to that differential equation. So we have been able to do other nth order when n is equal to 3. So let's take another example, example 2, where we are going to have it maybe y raised to power 4. That is, we have to solve y4 minus 9y squared plus 20y equal to 0. So this is another question. So how do we solve this? This is another question. That is, when we have the quart y all over ds squared minus y the square y all over ds squared plus 20 equal to 0. So what do we do here? How do we solve this? How do we solve this problem? That is what we are about to do now. Okay. The characteristics equation in this case will be m raised to power 4 minus 9m squared plus 20 equal to 0. Okay, that will be the characteristics equation. So what do we do here? How do we solve this problem? How do we solve this problem? That's what we are about to do now. How do we solve this problem? Okay. How are we going to solve this problem? Let's look at it critically. So I can rewrite this to say that this is m squared, everything raised to power 2, minus 9m squared plus 20. I don't want to write story. So that I will have m squared, m squared will be viewed as x. Okay. The two factors will be, this will be m squared minus 5m squared minus 4m squared plus 20 equal to 0. Then we do the grouping. What is common here? M squared is common here. We bring out m squared. So we'll be left with m squared minus 5. Then minus 4 is common here. We have m squared minus 5 equal to 0. So that at the end of the day, we have m squared minus 4 into brackets m squared minus 5 equal to 0. What can we say about this? What can we say about this? This simply means that m squared minus 4 equals 0, or m squared minus 5 equals 0. Then here we have, what do we have here? When we look at this, what are we going to get here? Here we have m squared minus 2 squared equals 0, or m squared minus square root of 5 squared equals 0. So the difference of 2 squared, we are going to have m minus 2 into brackets m plus 2 equals 0, or m minus square root of 5 into brackets m plus square root of 5 equals 0. That's what you are going to get there. So difference of 2 squared, that's what you are going to get there. Then here, it simply means that m minus 2 equals 0, or m plus 2 equals 0, or m minus square root of 5 equals 0, or m plus square root of 5 equals 0. So what are the values of m? In this case now, m will be equal to 2, or m is equal to minus 2, or m is equal to square root of 5, or m is equal to minus square root of 5. These are the four values of m. So that if we want to generalize now, we say this can be m1, m2, m3, m4. So the solution is y into brackets C1, or you can use these are C1, C2, C2, whatever they are arbitrary constants. You can call it, you can use another notation. Maybe here that will be C1 exponential 2x plus C2 exponential minus 2x plus C3 exponential square root of 5x, then plus C4 exponential minus square root of 5x. So this will represent the solution to this particular problem. So these are homogeneous, linear homogeneous differential equations when we have nth order. In this case now, n is equal to 4. The first example, n is equal to 3. We can also have a question if maybe n will be equal to raised to power 5. That is d for 5 dy over ds5. We can have it to be 6 and so on. At least as when we say nth order. So that's the general order. So I would love to stop here because of our time. We are going to continue from there in our next class.